Techno is a company celebrating its 40th anniversary this year. It was founded as a specialist in technopolymers and plastic injection molding. And over the last 15 years, it has experimented with various new applications in the electromechanical, electrotechnical, and electronic fields. In the last 5 years or so, technological evolution and the need to provide customers with fast, high-quality service led us to reflect on how to evolve the product development and application side. So we also introduced an internal division called the Innovation Team, dedicated to product innovation in both product design and technology. This led to the decision to invest in the additive world and the creation of a 3D lab dedicated to all product development. Within product development, the 3D lab can support us in the initial phase of idea experimentation and product design, in the preliminary phase of product design validation, so not just CAD modeling, but also in terms of installation, assembly, and setup, and in a final phase where additive is often used to create tools or jigs for assembly or product configuration. So within our development cycle, we can draw various functionalities from the 3D lab that can best adapt to the company's needs. And the Smartbox was born in a hybrid period, in the sense that we use the Smartbox to validate both a product design and the materials. Because it was born about a year ago, more or less, because we had internally launched a redesign of one of our historic boxes called the 209, we needed to remake the lid, increasing the space inside. As with everything, one might think, okay, it's one of the two molds to be remade, let's just remake the mold. The difference, however, was that to remake a mold of double the size, it meant completely remaking the insert. So we did a simulation to see what it means to approve the product first in additive, how much time do we save? Before working on a mold and giving the products to the technical, commercial, and marketing departments to evaluate. Then to see if the space was sufficient, because the second question was, we're increasing the space by X, but is it enough? So to do all this work, additive manufacturing was fundamental. We did a native additive project, made some parts, approved it for external IP, and so we did everything as if it were a final product. We made a pre-series and went on to perform some simulations. Installation simulations to understand if the space was necessary. After this first round, we released the mold, which was practically perfectly compliant because we had already approved it, and we also had the entire pre-series ready for all the commercial aspects. So it's a win-win because it saved us so much time in the setup phase. We already had prototypes that were presentable and installable. Thirdly, we also validated the product design. The choice of silicone was, you could say, the icing on the cake of the last 2 years of experimentation. The great revolution we see in this material is that after pre-approving it internally for performance, we tested it by simulating the approval cycle of a product we made with liquid silicone or with injection molded TPE. Having passed this gate, it's clear that for us it becomes an alternative material. This piece here today has two functions. It can be used to compensate, like a gasket for an airtight element, like a box, or a closure for electrical applications, or to guide and accept the cable that enters our connector, and then manage the tightening torque. So sealing, mechanical coupling, but also reliability over time. So the need to protect against water and dust, but also to resist mechanical and thermal shocks. So the choice of silicone comes from the possibility of experimenting also with Stratasys support on some new solutions that have led us in recent months, not only to validate it as a product usable in real applications, but also to validate it as a possible alternative, almost pin to pin compared to the liquid silicone molding we already have in place at the company. So in short, the need is both technological for Techno, because we can accelerate time to market for prototyping and small pre-series, and also for completing the growth of the company's additive manufacturing know-how, because now, thanks also to silicone, we've compensated for some of those installation problems we had originally. The great work we're carrying out in parallel internally, but also with partners including Stratasys and material producers, is to increasingly find a technological process compromise, but a technological one combined with materials, so also in terms of performance and process cost, to be able to create an intermediate step that is no longer just a pre-series, meaning I need it to validate the product, I need a few pieces which will never be mass production. Because injection molding is unbeatable and will be for many more years, but it's an intermediate that can allow us to make a few hundred pieces without having to make what's called a pilot mold, but with the same or very similar characteristics both to the additive theme that's already been pre-approved and by getting closer to the polymer we'll use in the future. For sure, what I've noticed over these last 3, 4, 5 years is having officially brought a lab into the company, having made people experience the turnaround times, how fast they are and what performance can be achieved. From aesthetics to threading to coupling, even trial and error done in a single day instead of a month. All of this is added value. So additive is a tool. Like all tools, they can be seen as positive or negative. But it's certainly a tool that allows anyone to experience firsthand some of those phases that were previously very complex and slow, like being able to do it in hours.